So today we are introducing the concept of a limit. And before I get into an example, what I wanted to show you is the definition so that we can kind of piece through that. And then I want to really just show you two cases that we're going to look at today. So mostly through tables today, we're going to try to find the limit of a function. And so the definition of a limit is if f of x approaches a unique value L, and the key word here is approaches, meaning it may or may not actually get there. As x approaches c from either side, then the limit is of f of x as x approaches c is L. And the way that we're going to write that is this. And so I know that there is a lot to sort through there, but I thought I would give you a visual of what C and L mean. So the first thing to make sure that we note, I'm going to draw this on a different piece of paper, is that if I'm looking at a picture of a graph of something, f of x represents the y-axis, okay? And so then let's say I had some function, and the function could go through, but perhaps there's even a hole in the graph. And I'm going to make this y value be L, okay? And that's the L that I was referring to in the problem. And this specific x value we'll say is C. And so L represents some number and C represents some number. So basically what this means is as I'm approaching x, as I'm coming from this direction, the y value is coming down, 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 down. Okay, so it's approaching this specific y value. But also, if I started to approach this specific x value from the other side, so if I started coming in this way, here's my function, it also approaches that same value. So from both sides, it is approaching that same y value of L, okay? Maybe that's an 8, maybe that's a 10, I don't know. So when we write the limit as x goes to c, what I'm saying is as x gets closer and closer to the specific value, the y value or the function gets closer and closer and closer to this y value. And so that's when I'm asking you to find limits today, I'm going to ask you, what is the y value that the function is approaching? Now, if there's a hole in the graph like this, what you're going to see is we're going to still be, even though the function doesn't go through that point, through a table, we're going to still be able to figure it out. That's what our second example is. Some of the tables we do, the function's defined there, so it makes our job easy because it actually goes through that point. But you can still find a limit if there's a hole in the graph as long as from both sides the y value approaches the same thing. So the second thing I would like to talk about then as I'm flipping back in our notebook is how we are going to set up the table function, okay? And so one of the things that is going to happen, and we start the example 2 in another video, but let's take a look at example 1. And so what I want to point out to you is this is my function f of x. It's a line. I'm going to go ahead and get my graphing calculator out, and I'm going to graph y equals negative 3x plus 1. Notice there is no denominator. That means there are no, this is a line, there's no spots where this is undefined. If I look at the graph, there we go, we have a line. I can trace up and down. So in this one, it becomes kind of easy Because if I said, hey, what is y approaching as x goes to 2, I could just plug 2 in. -3 times 2 is -6. -6 plus 1 is -5. You're going to see in this next example, I can't plug 3 in, so I have to use a table because there's a hole in this graph. But I'm going to use this as my example. So for today, we're going to be setting up some tables. And to do that, I'd like you guys to use the same method. So what you're going to do is put the value for x that you're looking at in the middle here. And then you're going to kind of start zooming out. So I have 2.001, 2.01, 2.1. That's just to the right. And then 1.999, 1.99, 1.9. You're going to notice I use that same idea in the next one as well. So let me teach you how to set up a table. So first, you're going to put your function in for y equals. Second, you're going to go to table set. So I'm going to show you that. Table set is second window, and you'll see this screen. Very important, what you're going to want to do is make sure you set up your independent variable, just this one, for ask. So make sure it's set up just like mine, and then auto. Okay, this part up top doesn't matter. So this is the big deal. Ask for the top one and then auto for the second one. Finally, we go to our table. So second graph. Now, because I set the table up this way, what I can actually do is type these values in, and I'm going to type them right in a row. So I would suggest on your homework today, you write this out and then type in the top line in order. So I would type in 1.9, 1.99, 1.999, 2. This one happens to work at 2, some others don't. 2.001, 2.01, and 2.1. All right, so as we're looking at this example, what you would do next then is, it's very clear, I would fill in the table, and I fill those values in from right and left, and my answer is what I get when x actually gets to 2. And so my answer here was -5. Most of the ones we do today, though, you're going to have a blank there, so you're going to have to fill in that blank, and I'll spend some more time talking about this example next. I just wanted to give you a little visual of what exactly a limit is and how you set those up. Make sure to watch the next video so that you can see, once again, how we write a table and how we find a limit when we have an undefined spot. So an undefined spot means if we plugged in 3, I'm dividing by a 0.